Hey everybody, Mrs. Bianchi. One side of a rectangle in the coordinate plane has vertices at -5, 1, and 4, 1. The perimeter of the rectangle is 26 units. What are all the possible coordinates of the other two vertices of the rectangle? Show your work. So let's go ahead and plot these on the coordinate plane so we can visualize it. We have to go left 5 and up 1, so let's go left 5 and up 1. And we have to go over 4, up 1. All right, so that means that we have one of the sides of the rectangle would look like that. Now, what do we know about rectangles? We know that the opposite side of the rectangle, which could be either above that line or below that line, will be the same length. And we also have to figure out what that length is. So let's calculate the length. There are two ways to do that. One way is you look at the two ordered pairs, and you ask yourself which coordinates differ from each other. In that case, it would be the x's, because remember the y's are the same. If they're in different quadrants, which they are, then the rule is to add the absolute values of the coordinates that differ from each other. So we're adding the absolute values. We're adding the absolute value of a -5 plus the absolute value of a 4, which is 5 plus 4, and we end up getting 9. So the length of that line is 9. I'm just going to put a 9 there. Now, if you couldn't tell that it was 9 by doing that, your backup plan, as long as each line represents 1 unit, which that would be true in this case, you could simply count 1, 2, 3, 4, 5, 6, 7, 8, 9. That strategy would work to figure out that it's 9. Now, the other thing, too, that we have to consider is we're talking about perimeter here. What is the formula for perimeter of a rectangle? It would be perimeter equals 2 times the length plus 2 times the width. They give us the perimeter. They give us the perimeter until it's 26 units. We need to substitute that value underneath the P because that is the perimeter. Now we also know one of the dimensions. We know one of the dimensions is 9, and we also know that we're going to have 2 of those because opposite sides of a rectangle have congruent lengths. So again, we don't know if it's going to be above it or below it, but we do know we're going to have an opposite. We have 2 of the lines that'll be both 9. Now what are we trying to figure out? They want to know, we have to figure out what the width of this thing would be, because we're going to use that to figure out what the vertices of the other parts of the rectangle could be. So let's finish solving this. To simplify, we'll go ahead and do 2 times 9, which would be 18. And let's write everything that we have left. So we'll copy the 26. 26 equals this plus this, 2w. All right, next, we're going to undo this. The opposite of adding 18 would be to subtract 18. Let's subtract it from both sides of the equation to keep it balanced. Everything in this blue circle will cancel out. We're going to bring down the 2w. And we have to go ahead and subtract these two values. 26 minus 18. So we can't take 8 away from 6. Let's make that 1 less. So this can become a 16. And 16 minus 8 would be 8. All right, so this means 8 equals 2 times some number. What's the opposite of multiply a variable by 2? It would be to divide it by 2. By the way, everything you see here should be on your piece of paper or on your Jamboard if you're using a Jamboard. This would simplify to equal 1, and 1 times w would be equal w. And 8 divided by 2 would be 4. All right, so here's what we know. We know that from this dot, we need a line that's going to go either up or down that has to be 4 units long. So if I count 4 units, let's say going up, so let's make sure we understand 4 units where I'm pulling it from. See, if this is 1 unit, that green line represents 1 unit. So we have to count 1, 2, 3, 4 going up. So that puts a potential coordinate right here, or the vertices. One of the vertices could be right here. Now that would also have to be true on the other side. We would have to count 1, 2, 3, 4 going up, and then put a dot there. All right, now if we visualize the finished rectangle, so I'm just going to put all the lines there so you can see it, that's a potential place for the rectangle. So I'm just going to put letters here even though they don't ask you to. I'm going to call this point A and this point B. But what you need to figure out right now, and I would write this on your piece of paper, is figure out what's the ordered pair for this point right here. So notice we're going left 5 and up 5. Write that here. And for point B, I would have to go over 4, up 5. Over 4, up 5. Now keep in mind that we can also go the other way. By the way, let's put the dimensions on here just to make sure we all understand how this, what does this have to do with the number 26? So if this is 9, then that means this opposite line is 9. And if this is 4, then this is 4. So you would want to make sure that if you add up all these numbers, that you would get 26, because remember, perimeter is the distance going around. So 9 plus 9 is 18. 4 plus 4 would be 8. Add those two things, and you do get the 26. All right, so let's look at it going down instead of up. If we go 4 units down from that original dot and 4 units down from the original dot, then let's look at the rectangle that we would have that might be below the line. What would be the ordered pair for that dot right there, which I'm going to call point C? And what would be the ordered pair for what I'm calling point D? Because that would form a rectangle also on the bottom. You want to write these down on your piece of paper, these points. Now, if you're doing the Google form, you'll see choices that you have to check boxes of, and you want to pick all the ones that match what you have written for points A, B, C, and D. All right, good luck finishing that up.